Survey of 498 U.S. adults finds that 71% believe teenagers are more dangerous drivers than those over 65. Construct a 99% confidence interval for the population proportion of adults who think that teenagers are more dangerous drivers. Okay, these are the steps. We want to identify the sample statistics X and N first. In this problem, N is going to be the number of people that are asked the question. So N is 498. Now in this problem, they give us the population proportion already. The way we calculate it is P equals X over N. That's a formula we'd used in the past for probability. It's an empirical probability because you're taking people who had said yes to the question and dividing by the total number of people asked. But in this problem, they don't tell you exactly how many people said yes to it. Instead, they just straight away give you the proportion P. So we could find X if we wanted, but we don't have to. We know that P is 71%, which is 0.71. If for some reason we wanted to know how many people said yes to the question, we could put 0.71 equals X over 498. Then we could solve for X with algebra, just multiplying X equals N times P, which is 498 times 0.71. Looks like 354 people had said yes to the question. So they had said teens were more dangerous. Okay. We want to identify the point estimate P hat. We have done that. Now, why do they put a hat over it? Because this is an empirical probability. It is not necessarily the population proportion, because they didn't ask all U.S. adults the question. But what we are interested in estimating is we want to estimate P, which is the true population proportion. Next, we want to verify that the sampling distribution can be used. So is our NP hat and NQ hat big enough? They have to be at least 5 in order for it to be approximately normal. We talked about that in the past a little bit. So N times P hat here is going to be 498 times 0.71, which is, oh, we already did that, yeah, 354. And then we also need N times Q hat. And so how do we get Q hat? Well, Q hat has the formula 1 minus P hat. So that's 1 minus 0.71. That's 0.29. $144. So we got 354 are the yeses, 144 are the no's. That is definitely bigger than 5 for both of these. So we'll say NP hat and NQ hat are large enough to use a normal sampling distribution. Or to assume a normal sampling distribution. So we verified that. Next, we want to find the critical values that go with this. Now, we had sometimes used Z and sometimes we used T. We used Z when we knew the population standard deviation. We used T when we didn't know it. For these types of problems, the binomials, we're just going to always use Z, because we really will know the standard deviation by being able to calculate it with that square root of NPQ formula. So we just always use Z here, and we want to find the ZC for a confidence level of 0.99. So I'll go to the formula sheets. 99% confidence interval happens to be one of the ones that is in this table right here. So the ZC is going to be 2.575. Let's draw our picture of our curve. We need 99% of the area in the middle. This is a Z of negative 2.575, and this is a Z of positive 2.575. Now we did that. We have to find the margin of error, and it has its own formula for a binomial. It's going to be ZC times square root of P hat Q hat over N. Okay. So we have 2.575 times the square root of 0.71 times 0.29 over 498 people that were asked. See what that margin of error comes out to. I get 0.0524. And now we're ready to construct the confidence interval. Alright, so the center of our confidence interval this time is going to be P hat. So that is the 0.71. So we're going to have 0.71 in the center. We'll do P hat plus E on the right. And we'll do P hat minus E on the left. 0.71 plus 0.05. And then 0.71 minus it. I'm getting 0.658, 0.762. Alright, so we can now make our conclusion. We are 99% confident that the true population proportion of U.S. adults who believe teens are more dangerous drivers than drivers 65 plus is between 65.8% and 76.2%.